Hi everyone, welcome back to my channel. And this is the day two of today's bootcamp. I will be starting with the GFC portal and problem of the day. As you can see that problem of the day given today was closest threesome, and the question is given that it was difficulty category of medium category, and yeah, and this particular problem was asked in Amazon, Microsoft, Google, and Apple. So this is very important for the interview aspect, and we have to find multiple approaches. Given an array of four integers and another number target, and find the three integers in the array such that their sum is the closest to the target. Return the sum of the three integers, and if there are multiple solutions, return the maximum one. So the question states that one array is given. In that array, we have to find any three elements which is closest to the target. If there are multiple solutions we have, then we have to pick the maximum one. That's what the question was. For example, the sample test is this is the given array and target is to find two. And we know that -7 and 8 and 1, if we add up three elements, we will get sum as 2. -7 and 8. If we add that, we will get 1 positive 1 and 1 plus 1, 2. So sum is 2, which is close and matches to the target. Then we can simply return that. That is the test case 1. Test case 2 will be given array and target is 30. We have to find the closest one. There are multiple solutions for this, but we have to pick the which triplets matches. As you can see, 5 2 5, 5 2 5, which is nothing but uh, 12, and second solution will be 2 7 5, which sum equal to 13. Yeah, so that we can find out with help of those sum, and 7 5 5 12 12 14, sorry, 2 7 5. So you can see that there are multiple triplets which result 12 and 14, but we have to pick the closest one. 12 is differ by 1, and 14 is differ by 1, but we have to pick the maximum one, which is the question stated. So that is the our intention of this problem. We have to think an approach, we have to identify the problem, and we have to identify the which algorithm is suitable for this question. That's what the interview was looking for from the candidate. Okay, the expected time complexity is n square and constant space, and the constraints are given. Array size, at any cost there will be three elements minimum, and maximum will be the 10 per 1000 elements will be there, the length of an element, and each element will ranges from -10 power 5 to 10 power 5, minus lakh to 1 lakh. Yeah, and the target will be starting from 1, the positive values, and it goes up to the 10 power 5 itself, which is nothing but 1 lakh. That's what the question. We have to discuss the constraints before going to the solution. Okay, and for this I have a solution which will be using a two pointer approach. I can show you here. Yeah, as you can see that uh, this is the day two and this is the day one. Please watch it. Yesterday have recorded and have provided detailed intuition and visualization and all two approaches. Go and watch. I will be attaching those links in the description. And yeah, I will go in with the today solution, today problem. This is the question, and I will be using two pointer approach. One, first of all, we need to sort the array. This is the pseudocodes. Why I'm explaining pseudocodes in the interview? Also, you have to explain the pseudocodes first. Then you can code in different languages, either which you are comfortable with, either Java, Python, C++, any one of those. Yeah, that's how the interview will be going on to crack any FAN company. And we have to sort the array first, and then initialize the closest to the minimum value, the smallest, nothing but int min, and then we have to iterate up to less than. less than 3. We should not go beyond that. Before that, we can iterate. So that is one of the trick. No need to iterate and three elements. It will be covered as we are moving further. And we are using two pointer as I said earlier. Why we are sorting? Sorting gives the all the elements in a ascending order, so that we no need to check the middle elements. We no need to iterate for targeting or required elements. So that's the reason sorting is necessary. It will take n log in time. And yeah, I pointer starting from 0 and j pointer is nothing but an plus 1. We are adding plus 1, nothing but adjacent element. And k will be the last pointer, which will be length of an array. We will be coming back to the maximum element, maximum value as we are sorting. The maximum value will be resetting at the length at the end. So that's the institution. And we will be using two pointers as I said. J is less than equal to k, which means that j pointer should not cross over to the k, and we will be adding all the sums. And if the sum matches to the target, we will be returning that. And then we will be checking for the closest. If we don't have the matching target, then we should check for the absolute difference between the sum and the target is less than the absolute difference between the closest and the target. So that particular closest will be updated here. And else if we have to check for the condition whether both the absolute difference sum and target is equal to the closest target, closest and target. So if those are matching, we need to update the maximum among those, which is the close. If we have the two solutions, like two criteria, like a 12 and 14, the test case I have given, right? This is the 12 and 14. You can see 12 and 14 are two solutions, but we will pick maximum out of it. For handling those scenarios, to take the maximum, this is the else if condition. And this is the condition to increment the pointers. If the sum is less than the target, so we need to increment the j pointer to increase the sum to reach the target. Else, we have to decrement the sum, which is nothing but sum is greater than the target. That's how we find, and at the end, we will be returning the closest. This is an algorithm, sorting and initializing the variables. Everything has been defined as we have discussed, and I will be going with the Java code, and later on there are Python code and C++ code for your reference, and the dry run also there. I will be explaining everything. And let me take the highlighter. Yeah, as I said, we need to sort the array, and after sorting, all the elements will be in an ascending order, as you can see here. As you can see, this is the dry run of the elements. All are sorted, and then we are taking the closest as an int min, and then after taking the int min, the closest value. Why we are taking int min? Because our target is to find the maximum closest value. We have to find the maximum among those. I pointer is the initial pointer going up to the -2. We should not touch last three elements. It will be always covered as we are using three pointers. Yeah. And yeah, j is equal to the adjacent of I, and k will be the last pointer. Nothing but, for example, this is an array bunch of elements, and I pointer, j pointer, and k pointer. We will be adding these three elements, and we will be shrinking the array based on our sum. And as you can see, j should not be crossed out to the k, and we are adding all the elements and checking the target. If it's matching, simply we can return the closest sum. If not, we have to check for the closest one. With the help of absolute, right, we will always get an positive value, and we will be checking here the minimum minus closest initial will be the minimum, right? Minimum minus target, so that we will get an approximate much more greater value, and then we will be storing that value. If the sum is less than the above one, then we will be closing. We are taking the maximum among those. And else if condition, right? This is the condition where if we have the two solutions, one will be the sum minus target equal to the closest minus target, nothing but 12 here, and this is for 14. And if that is the case, the difference is nothing but 1, right? The target element is 13. and here the difference is 1. So if that is the case, we have to take the either 12 or either 14. So which is the closest one? 12 will be the previous answer and 14 will be the current iteration sum. So we are taking the closest, nothing but 14, and we are returning that. That is the case as I shown at the bottom. See, initially we are taking I value is 0 and j is the adjacent of it, and k will be the last index, which is nothing but fifth index, and the value is 9. And respective values are placed here, and we are adding the sum. We will get a 3 initial in the first iteration, and we are checking 3 closer to 2, and then um, we are checking for the minimum among those. We are taking the closest, right? So the 3 will be assigned to this instead of minimum, and then always taking the maximum among those among, and I is pointing to 0, and as we know that the sum closest sum is greater than the target, so we have to decrement the k pointer in the same algorithm. See, as you can see, this is the condition where the sum is greater than the target, we are decrement the k pointer. So we are decrementing the k pointer. We are adding the same sum with the decremented k. The fourth index pointing towards eighth element. Here the fourth index and eighth element, and the sum is matching, exact matching to the function. We are simply returning that. This is the first diagram of the code. And second diagram, we are sorting it. This is the sorted diagram. And as initial minimum value and iteration started, initial I, J, and K. K will be the last element 7, and we are summing up. This is the 14, and we are checking the target element is 13 as we are given, and this is the 14 element, and which is the closest one and the maximum among those. The 14 is the maximum, and we are not stopping here because we got the 14, but we are checking for the exact match. So that's the reason we are going ahead and we are increment the j pointer, because sum is we are getting sum is less than the target, so incrementing the j pointer. So here j pointer is increased, and we will get a sum of 14, and closest will be remain the same. And next iteration we could not find the 13th one, and we can return that sum. That's all. So as you can see that the we can find the in the first example we can find the exact match, and simply we are returning that. In the second example, after sorting the we can find the target value, and in the target we have two solutions, picking the maximum sum among the case. That's the particular problem itself. Yeah, thank you.